Hello all, welcome to another quick learning. Today I'm going to go over the binomial distribution in Excel, how you can calculate different probabilities of certain events, and how to simulate it. So first of all, a binomial distribution is used when an event can occur with two outcomes. For instance, if you have a coin flip, you can get either a heads or a tails. Or if you have a football game, you can either get like the Patriots versus Bills, you're either going to get the Patriots win or the Bills win. So to simulate that, I used an if function, and then I used the rand function, which gives me evenly distributed number between 0 and 1. So each number is equally likely between 0 and 1. And I set that less than the probability of heads, which is 0.5. And so if it's less than 0.5, I put head, H for heads, or if not, I put T for tails. After simulating that 1,000 times, in this particular example, I got 522 heads, and then 1,000 minus that is 478, so I got 478 tails. So you might expect there to be exactly 500 heads, but that's actually kind of unlikely because in your experience, if you flip a coin 10 times, you might get 5 heads, 5 tails, but also likely is getting 6 heads or 4 heads, and so on. But the more you do it, the more likely it's going to be close to the expected number. In this case, it would be 500. So if I want to calculate the probability of getting at least that many heads, so 522, then I can use the binom dist function, and what I plug in is the number of s. So in this case, the s means successes, but you can define success as whatever you want. In this case, success would be heads. And then the number of trials is 1,000 because we simulated 1,000 coin flips. The probability of s, or in this case heads, is 50% or 0.5. And then I used the true condition for the cumulative, which gives me the cumulative. So it recalculated. This time it's 495 heads. And I'll show you what this 0.39 means. So here I've graphed out what is the percent probability of getting a certain number of heads in 1,000 simulations, here from 400 to 600. So if we find where 495 is here, it's slightly to the left of the top of the curve here. So if we take the area under the curve to the left of this, that represents the probability of getting that many heads or less. And that's 0.39% of the area under this total curve, which should equal 1. So if you took the area under from 0 to 495, you would get 0.39. And then consequently, the area to the right of that value is 61%. So if you take the area under up to here, up to 1,000, you would get 61%. So the probability of more than 495 heads is 61%. And that makes sense because your expected number of heads is 500, so you would expect that you would get over 50% times more than 495. Now if you just wanted to know what's the probability of getting exactly 495 heads, not 490, not 500, but exactly 495 heads, it's 2.4%. And again, you can use the binomial dist to calculate that, but instead of putting in true for the cumulative parameter, you put in false, and that gives you exactly that. So now if you looked at this case, it recalculated and it went to 506. So if you went to 506, it's somewhere around here, and that's where 2.35% is, right around there. Now the probability of an event is not always going to be 0.5%, or 50%, sorry, or 0.5. So in the case of like a NFL game, you've got Patriots versus Bills. The Patriots are a better team, so they're going to have a higher probability of winning. So let's say that's 90% or 0.9. So if we simulated that 1,000 times, in this case, the Patriots got 901 in this simulation, and the Bills won 99 times. And you can calculate the same probability of getting at least that many Pats wins. So it would be 56%. That's the area to the left of the curve. And then the probability of more than that many Pats wins is 44%, which is the probability to the right of that curve, area under the curve. The probability of exactly that many Pats wins, so exactly 901, which is right about at the top of the curve, you can see is 4.2%. So what's interesting is you'll find that the binomial distribution changes shape based on the probability of the event. So you can see at 0.5 you have a mean here of 500, so you expect 500 heads in 1,000 trials, because the probability is 0.5 times 1,000 gives you 500. And then, I'm sorry, this should be the variance, and then the standard deviation would be the square root of that. I can't type today. Equals square root this number. There we go. All right, and then you'll see if you have a probability of 0.9 that your mean is going to be at 900 and your variance and your standard deviation are going to be lower. You can see that the top of the peak is higher and the variance is not as wide as it is when you have a 0.5 probability. And you can calculate the variance by taking the expected number, which is 500, or the mean, times the probability of a heads, so in this case 0.5, times the probability of the other outcome, which is tails, which is 1 minus 0.5, which is 0.5 again. So if you do that, I'll escape out of that, you get 125, and the standard deviation is just the square root of that variance. Whereas if you do it here, you take the mean of 900 times the probability of a Pats win, which is 90%, times the probability of Bills win, which is 1 minus 0.9, which is 10%. So if you do that, you get 81 for the variance, and you take the square root of that, you get 9. So that's how you use the binomial dist functions in Google Sheets to calculate various probabilities. Hope you guys learned something, and you can now simulate and use the binomial functions in Excel. All right, thank you very much.